do this before, the IoT New York meetup. Okay, first timers. Okay, welcome. Great. We usually get kind of like a 50-50 mix, and to folks who are regulars, it's great to see you guys. We've built a really great community and some interesting collaborations that come out of that community. And for the folks that it's your first time, definitely invite you to keep on coming back and spreading the word about the meetup. Providing the venue, food and beverage, and the speaker tonight is Microsoft, so we very much appreciate that. I think this is the first time they've been sponsoring, so as you guys can imagine, through the IoT ecosystem, there are larger strategic companies that sponsor, and there are also startups, and we welcome both. I basically try to keep a nice balance between topics like this that people really want to understand and plug into, in terms of Azure and understanding what Microsoft is doing around IoT. And we also want to have a great balance of showing kind of up-and-coming startups and kind of different topic areas within IoT to dig into. So, you know, we'll have topic areas like open source and IoT, security, legal aspects of IoT. The topics tend to be functional with a technical bent. So just so I kind of understand the new audience coming in, how many folks would, so the choices are, it's always good to know upfront what the choices are functional versus technical. So how many folks here would consider themselves more of a functional person in tech? And don't be shy. How many would consider themselves technical, like engineers? Okay, great. So we have a nice split, and typically the people that are coming out, you know, they know enough to be dangerous around technical folks, and then the technical folks also want to understand the other side of things, the business implications as well. So we definitely try to do that. I definitely invite people to look through, again, this is the 37th monthly meetup we've had, look through the previous topics, see if one hasn't occurred in a while and you'd want you know, to see that again, say open source and IoT. You can message me, you can reach out to me directly, you can reach out to me on Twitter. What I'd like to do is very much keep this community about, you know, you guys and about what you want to learn and hear about each month, and just a way for people to get together and trade ideas. Great. So on to our next sponsor. Thank you to Jolly behind the camera there, doing videography. Jolly is with the Internet Society, so we appreciate that. And then also a thanks to our volunteers who you met downstairs giving out the name badges and checking you guys in. So Joseph DRC, where is Joseph? Okay, oh, there, our volunteers are right up front here. And Ahmad Elokush. Thank you guys very much, we appreciate it. Okay, great. So just to let you guys know and give you a heads up about upcoming IoT New York events, anyone in the room go to the Brink office hours? I think it would have been last year. There are very limited spots. Oh, you guys went. Okay, great. There's an office hours put on by Brink, which is an accelerator out of Hong Kong, and they help companies become more successful on hardware and go to market and understand the factory and manufacturing and distribution landscape in China. They're based in Hong Kong, and they've spoken, I think it was last year. Bei, who is one of their leaders, gave an excellent talk to really give people a behind-the-scenes look at when you're, you know, if you're based here in the States and you either haven't done business in China or haven't manufactured in China, these are things you kind of want to consider. These are the things that we wish we knew, and really kind of gave everybody the lowdown and the scoop. They kind of bring that same ethos to a lot of what they do. So in any case, you know, keep your eyes open for that announcement. It will be scheduled for November 17th and 18th, and one of their leaders will be here for office hours. So if you're an entrepreneur, and whether you're looking for funding, looking for feedback, advice, looking to kind of trade ideas and kind of, you know, check the validity of certain assumptions that you have, I'd encourage you to check out that opportunity. When I announce it, it will be, this coming week I'll announce it, and it'll be first come, first served, and there'll be a Google Sheet sign up for that. And then the next IoT New York meetup, it will either be Monday or Tuesday, but most likely Tuesday, November 29th, which is the Tuesday after Thanksgiving. Okay. Yes? I'm sorry? Yes, so so you know that the meetup URL is meetup.com/IoT NY. So yeah, you can see it here, and then you'll find events. If you go to home there, you'll see all the events coming up, and this is tonight's event here. I'll later, in a few slides, be announcing these other opportunities to travel to China. Yeah. So, and then also while we're here on the webpage, I'd encourage folks to keep an eye on the discussion board. There's always, whether it's conferences or opportunities for folks in this specific meetup, there's a lot of folks in the tech ecosystem that this is the best way for them to get to you guys. And so they'll contact me and they'll give discount codes and other stuff. So instead of spamming you guys with emails, what I typically do is put it all on the discussion board, and then in the monthly meetup, I'll quickly announce the ones that have come through in the most recent month. I'd also encourage people, if you know of interesting, whether it's an interesting article or an interesting event coming up, feel free to post it as well on that discussion board. Great. Okay. I know this is the somewhat administrative part of the night, and you guys are all looking forward to hearing our speaker. But at the same time, for the kind of community type things, for this meetup community, I want to be sure to spread the word, because there are a lot of interesting things happening. Okay, so a few community announcements. As I said, please contact me if you'd like to present at a future meetup, or if you have other news to share with the broader community, and I'm happy to post that and spread the word. Okay, this is kind of the first time I'm announcing it this way, but I have some pretty exciting news that I've kind of worked to cobble together an alliance of different IoT meetups in different parts of the world to announce and announce and share ideas about things that can globally benefit the community. So if it's specific to this region, I wouldn't announce it through this alliance. But I've reached out to IoT leaders in all of these key cities, and these are some of the largest ones in the world. Bangalore actually is now the largest IoT meetup. It's over 10,000 members, which is very impressive. We're at over 4,000. San Francisco's over 5,000, and they're at 10,000. So in any case, there's some really interesting ideas that can be shared through these. So if members have an interest also in learning more about kind of that alliance and how that might shape up, please feel free to chat with me afterwards. But the point is, each of these meetups in key cities will be announcing this opportunity. And it's, again, with Brink, the accelerator I mentioned, that's based in Hong Kong. They're basically putting on a free China trip. It's not free as in, you get a 10-day stay at the beach and a first-class ticket. So you have to pay for your own travel, your flight and your hotel. But they've basically curated a week-long kind of immersion where you're not just being brought around to factories for a full week, because they're like, everybody would be spent by the end of that week. So they've really mixed it up to have factory visits, visit maker spaces, depending on which trip it is. Some there are kind of like the largest consumer electronics marketplace in the world that they'll visit. And so it's a very nice mix. And then, of course, there are mentors there through their program. So if you're finding that you're having trouble with something around prototyping or manufacturing, bring that thinking with you, and they really like engaging. Part of their motivation behind this is really just growing the ecosystem, and that's why I got very passionate about announcing this to all these other meetups, because obviously if they grow the ecosystem, they'll find out about great startups that might join their program, but they're really doing this on their dime, and I think it's a great opportunity. So that's a long spiel about it, but more information is on the meetup page, and I might shoot an email out to the membership as well, just as a reminder. I will say that spots are filling up very quickly, so the December trip is just about full. The February trip I'm considering going on. If anybody is considering going, feel free to talk to me afterwards, and we should keep in touch about that. And I'm told that if you book your flights pretty far in advance, they can be pretty reasonable. So I guess I should take a show of hands, because that was a lot of information, but just show of hands, anyone in the room interested in that kind of trip? I know it takes some availability, but okay, great. Thanks, guys. Okay. We're short on time, so I was going to bring up in current events. I won't go into the story, but anyone see the news, I guess it was over the weekend, about this landmark transaction that was happening around trade finance? So basically, it was a combination of IoT, blockchain, and smart contracts, and really interesting. I know we have Andre DeCastro in the room, and he knows a lot about blockchain, and maybe he'll speak to us at a future time about that. But for any folks interested in that, you might want to check that story out. They didn't get to the final transaction in terms of payment, but all these other pieces, they relied on blockchain, smart contracts, and IoT. So sometimes I'll bring kind of one interesting piece of relevant news to the meetup, just as food for thought. Okay. Rolling along. I'll put this on the discussion board, just a heads up that we have a discount code. How many people here are engaged in the election versus sick of the election? Okay, great. So if you watched all 3 debates, and we know that technology has not come up very often, this could be an interesting kind of group or gathering. So it's on November 3rd. It's around how presidential technology policy influences tech adoption, VCs, all that good stuff. Oh, okay. Jolly may stream that. Okay, great. Great. So, okay, so the link is there, and the comp code SFMVIP. Oops, wrong way. Okay. Anyone heard of or been to Civic Hall Labs? Okay, great. They're doing really cool stuff. They're doing kind of civic tech work. And they just announced they wanted you guys to know about this program, delta.nyc. It's a pro bono tech program. So they're seeking digital professionals for pro bono volunteers. I think they're approaching it differently than a typical pro bono project, so it might be a very interesting way to collaborate with other technologists. I have the application link here, and I'll also post that to the discussion board. Okay. I announce this every month, so I won't spend time on this. This is on the board as well. Just some information on some maker spaces if people are just interested in making and experimenting, or if you're working more seriously on it. Hack Manhattan and JC Fab Lab are 2 spaces that are available. Okay. For member announcements and asks, I only have one that was passed along a few months ago, but I believe this is still the case. HyperCorp, who was a speaker at a previous event, they're hiring. And the email is careers@hyper.com, or you could check out their website if you want to find out more. And that is the last of my announcements. Thank you guys for bearing with me. Now let's hear from you guys, because the rest of the night is going to be all about the speaker and then Q&A, and that'll be the end, and then you guys can chat at the end. But before we tee up the speaker, let's hear from you guys. Who has an announcement or an ask of someone?
So my name is Ahmad. I'm a programmer. I do some consulting. I run a consulting business. And I'm starting a meetup for iOS developers, all technology. I'm a programmer. I'm going to have programmers coming in. The reason I'm starting it is the meetups in New York for iOS have been, the biggest one is run by a recruiting firm, which blocks a lot of people from coming into and attending these events because they try to, filter people. So I want to build this to make it a community, kind of like what you have here. Open for everybody, anybody can attend. We're going to have technical talks, so through natural selection, if you're not interested, you're not going to be able to be showing up all the time. But it's open for everybody. Our first event is with IBM. They're going to talk to us about Swift and how this uses server-side language. The event is called NYC iOS Hive, as in like the busy bees, Hive. So, I hope to see you there soon. Our first one is on November 3rd. Thank you.
Great, thanks. And asks can be you're looking for a job, or you want to collaborate on something, or anything else. So definitely feel free to speak up, because these are folks that can help you or collaborate with you. Oh, go ahead. I think it's on.
I've got 2 on the upcoming events. The Radical Networks Conference is 4th, 5th, and 6th. It's in Bushwick, so it's a very good conference. I believe it's it's very cheap to get in. It's full of hipsters, so it's a good conference. And the other one is Platform Co-op, which will be at Civic Hall and the New School. And I forget the date on that, but it's about a week or 2 after that. And that's basically about new models within the sharing economy, cooperatives, that kind of thing.
Great. Thanks, Charlie. All right. Who else? Announcements, asks, any cool projects you've heard about, conferences?
Thank you. My name is Jonathan. I'm starting a company. It's called RevMax. We're doing fleet routing for autonomous ride-hail vehicles. So we're looking for someone who is an expert in the hardware side of autonomous vehicles. Maybe they don't work on it full-time, but they really understand the space, they love it, and they want to contribute to the development of our fleet management software. So you can reach out to me. I guess maybe the easiest is actually our website, revmax.io. It's revmax.io, and my email's on there. Thank you.
Great, thank you. Anyone else? Announcements, asks. All right, so now to tonight's featured speaker. So our speaker tonight is Nick Landry. He's a senior technical evangelist at Microsoft. And basically, he has 20 years of experience in the Microsoft ecosystem. He got his start as a kid at using a Radio Shack Science Fair kit, like many people probably have. But he's had much time in the space. And what he's going to talk to us about tonight is, as you can see by the topic, scaling IoT telemetry, command and control, and analytics in the cloud. So this is a great kind of complement to other topics that we've had, right? Because other months we might focus on one specific area, and even though in the course of a night we can't go super deep, we try to really kind of get a great speaker that can tell us all about an area. Some are kind of vertical, whereas this is more of a horizontal, right? Like how do you scale, how do you process data? And so I think it's a great way to kind of complement others that are very specific, and this is big picture. So Nick will be telling us about establishing a flexible cloud-based approach to gather, store, and process data. He'll get into an overview of Azure, so the IoT services, including telemetry ingestion, stream analytics, IoT hubs, and basically, a lot of folks are interested in kind of what's Microsoft's approach. If they have more of an open approach, how does that kind of jive with what people may have understood before and how they kind of fit into IoT? So anyway, we're very lucky to have him. Please welcome Nick Landry.
How you guys doing? Good. Nice numbers tonight. I love it. Always great when people take a lot of their personal time to come and learn about a great topic. So thank you very much, Linda, for a great introduction. It's an awesome meetup. I actually had the pleasure of attending the meetup a few months ago to attend another of those sessions. Met Linda over there for the first time, and really happy to actually host you guys over here at Microsoft. So welcome to Microsoft. So my name is Nick Landry. I'm a technical evangelist at Microsoft, which means that I do this, basically. This is what I do for a living. And I specialize in a number of areas. The beauty of being an evangelist is that I don't have any of the pressures of production, so I can focus on more technologies. And so I'm pretty much known as a cross-platform mobile developer. So I do a lot of iOS, Android, Windows development, some native, some with like tools like Xamarin or Cordova. I also for the past few years, I've been working more and more in the field of IoT and hardware. And I also focus on other cool things like bots, natural language processing, computer speech. And I also even dabble in game development and mixed reality and virtual reality. Plus, of course, all the cloud stuff that's needed to support all these needs. So I cover a lot of things. But tonight, I'm here to talk about IoT. So I'll introduce the topic a little deeper when I go to my agenda slide. My information is all here if you want to reach me. If you have questions about like resources, where to learn different things, if you need guidance, feel free to ping me, that's fine. If it's more of a technical question, I'll probably send you to Stack Overflow where the question probably belongs. And you can always send me the link afterwards. If I know the answer, I'll go answer it, but I like to scale. So if I'm going to spend time to answer a question, I want the world to be able to see the answer. And so all my stuff is on GitHub, ActiveNick, my blog at Age of Mobility. You can follow me on Twitter at ActiveNick. If you do tweet during the session tonight, what's the official hashtag for the group? IoT NY. So hashtag IoT NY. If you want to tag me in there as well, that would be great. I would love to get your feedback afterwards. Now, my quick announcement is that I also run my own meetup here in New York. It's a group that I've recently rebranded it. So the front page of the meetup is not exactly that name yet. It was Microsoft Mobile App Developers. Now I've renamed it to Microsoft Makers and App Developers. So this way I don't have to change the logo. And I don't have to change the URL, the logo, everything stands, you know. It's basically hosted, we used to meet here, now we're hosting it at the Microsoft Reactor, which is a new community space that we have at Grand Central Tech. It's in partnership with Grand Central Tech, which is a great incubator and accelerator here in New York. And the next meeting is actually going to be tomorrow night. So you're all invited. If you want, you can go RSVP now. It's going to be a fun session about how to build for the Microsoft HoloLens. And if you guys have heard of the HoloLens, it's probably one of the hottest piece of tech ever. And I'll be doing an actual session tomorrow. I have my own HoloLens, and I'll be showing you how you can build for this. So it's a good group. We're not, of course, at the 4,000 plus members that you guys have, but it's a good group that's growing. And on November, I'm sorry, it seems that we're going to have a conflict in November. But my slide was already there, so I didn't change it behind the scenes. Whereas since we cover maker topics, we're actually going to do a session. One of my colleagues is an electrical engineer, and he's going to do a session on electrical engineering for programmers. As more and more programmers are jumping into the world of IoT and makers, and they don't really necessarily understand the fundamentals of electricity, electronics, and all this whole side of engineering and the hardware, well, he swims in that world very well. So he's going to be presenting it from the perspective of a software developer, someone like me who's basically spent their entire career just in software. So that's it. So you can just go meetup.com/mmadnyc. You can just go join now for free, and then just check the announcements that come out. If it's a topic that interests you, you can come over. If not, we'll see you next month. Okay, so tonight I'm going to talk about, first of all, the world of IoT, what the revolution is about. So just curious, who here is pretty much would consider themselves to be already working in the world of IoT? I know it's a very loaded word, but so it's not a lot of you. So there's a lot of people here that I assume are kind of new at this. Who's completely new to the world of IoT? I'm sure it's a lot of you, so just, okay, cool. We'll talk about this IoT revolution. What does it mean? So there's going to be a bit of a recap for some of you, new stuff for others, some of the challenges, and also where do we fit in, Microsoft, into all this? It might not be a big surprise to you to learn that we've been in this world for over 25 years now. So it's just that it used to have a different name. The world of IoT has kind of exploded the last few years, but we used to call it like embedded systems or embedded computing or pervasive computing or machine to machine. You know, so all these words have been used before, and now we call it IoT because the cloud has basically now allowed us to kind of scale system that used to be kind of in a closed loop, and now we can just like explode it worldwide thanks to the cloud. I got a live demo here, so I got my little setup here. Most of the action is going to be taking place on slides, and whatever I have here, I have a little camera you'll be able to see. But the hardware is not the rather the star of the show tonight. If I have time, of course, we're running a little behind. I might be able to tell you a bit more about some of our new offerings that we have in Azure. And of course, the thing I think is important is that since a lot of that stuff is going to be new, either to the IoT newbies or even to the IoT veterans that might not know about what we have to offer, I want to make sure that you can actually go get a lot of great resources out there on where do you get started with this. You know, where do you go from here? My slide deck, by the way, is already all on my SlideShare. So the link is going to be at the end, but it's slideshare.net/ActiveNick. You can kind of see a theme here. So that means you don't have to take pictures of every single slide, or if you do, at least make sure that I'm framing it. You know, it's like, geez. So anyway, so all the information is all here. So IoT, what is this? What's the revolution? We have an interesting, it's one of our colleagues actually at Microsoft in our Windows IoT team that had this description. I loved it so much I had to reuse it. Does anybody remember this phrase, this saying, a chicken in every pot? Where's that from? Hoover? That's what most people will say. Hoover did use it in 1928 during his election campaign, talking about a chicken in every pot. And it was also a chicken in every pot and a car in every garage was his expression, basically to make sure that, meaning like we don't want people to be living in poverty or anything. But it was actually Henry IV of France who said, and to phrase it properly, he said, I want there to be no peasant in my realm so poor that he will not have a chicken in his pot every Sunday. Apparently for the king, once a week was good enough for the peasants. I'm sure he had it more often. But anyway, so that's an interesting saying. And then jump ahead a few years to this saying. Who said that? It's kind of an easy one, I think. Remember where you're standing. Yeah, okay. So it was, yes, it was our founder, Bill Gates, co-founder Bill Gates. We said a computer on every desk and in every home. You have to remember, when he said this in the mid to late 70s, now it sounds obvious. But back then, the notion of a personal computer did not even exist. And a microcomputer was basically just a box with LEDs and switches. So to claim that we would have a computer on every desk and in every home was a very bold statement. Now today people go like, well, duh. You know, in fact, we've been filling the gaps in between now. We've been doing a lot of mobile. Basically, it's not just about the desk and the home or at work. It's about everywhere in between. And
How expensive at that time?
sorry?
How expensive?
What expensive?
How expensive at that time?
Oh, at that time, I don't remember how much. I mean, of course, mainframes would cost like millions of dollars. So only the largest companies. The microcomputer, I don't even remember how much those were. So again, it was like the Altair was basically just switches and LEDs on it. So the bottom line is, if it was affordable, it was very limited use, and if it was very useful, it cost millions of dollars, and it required like entire floors to basically house those computers. So IoT, it was one of our executives, who was now a general manager in our Windows division at Microsoft, who said that the world of IoT is basically a computer in every pot and chicken. Kind of merged both of them together to explain what is it exactly, the world of IoT. It's about putting computers everywhere. It's about putting sensors on everything so that we can gather data about the world around us. And I thought this was so apt, I had to reuse it. And I met him actually a few months ago again, and I told him that I've been quoting him in my IoT sessions. He was like, really? So anyway, so if we look at the world of IoT, it's this revolution where everything that can be connected basically should be connected. Most devices in the world today are not connected yet. I mean, the last thing I need in the world is another offline device that I have to charge every night. So 6 years ago, IoT was mostly limited to a few smart appliances, mostly the computers and devices that we have, plus a few extra things. In some areas, like for example, distributors would use it to basically automate vending machines to know when to replenish the machine, so that you go when it's empty and you don't go when it's been empty for a week or when it's still full. But move forward a few years and now the world of IoT has exploded like crazy. Kickstarter is full of projects that people are building for new devices that do new things. We've got home automation that's basically taking over the world. We've got connected cars and smart cars, and we've got all these like smart devices that we wear, like fitness trackers and things like that basically give us data about ourselves. So the world of IoT is basically gathering data about everything in the world around us, but then what do we do with that data? How do we act on it? How do we analyze it? So that's some of the things that I want to talk about tonight. So if we look at some of the key enablers of this revolution, it's basically, first of all, the hardware is getting really, really cheap. You can actually buy like a Raspberry Pi today, which is like $35, and it's going to be a 1.2 gigahertz machine with 1 gig of RAM. It's a 64-bit architecture with a GPU, a bunch of ports, and it's $35. That used to cost like $1,500 like 20 years ago. And it was not even close to that amount of power. So the connectivity is also getting pervasive, where now we can get connectivity everywhere. Sure, we live in a first world country. We have it easy here. But even in other parts of the world, like in India, in remote villages, and in Africa, there's all these projects to try to bring connectivity to people. Even though these people don't have electricity and they don't have computers, most of them have cell phones. And we're trying to bring connectivity to everyone. This is what's connecting the world. The development is getting a lot easier as well. All the tools are free. There's all these open source projects. We have open source software. We even have open source hardware. What's open source hardware? It's not hardware you can download from GitHub. Okay, that would be cool. It's basically the specifications of hardware is open. So that means you can download the specs for something that somebody's built, like an Arduino, and you're not basically in breach of anything. You can actually just take the spec, call your favorite manufacturer in Shenzhen and say, hey, I need 1,000 of these. You can modify it to your heart's content as well. And then there's going to be all these new innovative scenarios. Some of them are going to be the ones that you build. There's been the bread and butter of IoT now has been telemetry to do predictive maintenance. Basically, so that we can know what is about to break so that we can fix it before it breaks. Like one of our biggest IoT customers in ThyssenKrupp, they have like a fleet of 1 million elevators worldwide for their customers that they're maintaining. And we've all been in a broken elevator before, or we've had to deal in the lobby of a broken elevator and see the delays and everything. And it's always at rush hour when people have to check out of the hotel or people are going to work. What if you can find out ahead of time that the elevator is going to break because there's sensors all over the elevator that tell you if there's friction, if the ball bearing block is basically, if the oil is leaking, so the pressure is going down and the friction is going up, the temperature is rising, and you can analyze those trends in the cloud and then know ahead of time, hey, this is going to break within 2 days. So let's dispatch someone to go fix this at 2 a.m. when it's not going to impact people too much. Predictive maintenance, yeah, it's been around for a long time. But now we're opening it up more and more. And if we look at the IoT revolution, there's Moore's law, of course, keeps going strong. Some people say it's slowing down, but it's still not relenting, really. So Moore's law, which basically states that microprocessors are doubling in amount in power for basically every like 18 months or so. But now there's been Metcalfe's law as well, which basically says that the value of a network is the square of the number of devices that are connected to its network. So the more devices we connect, the more value we get. And we just have to look at the internet, how we can't live without the internet now and the value it has on our world. Kumi's law is actually an interesting one because Kumi's law tracks the computations that we get per kilowatt hour. And it's showing how chips are not just getting faster, but they're consuming less energy, which means now we can have better mobile devices. We can have like head-mounted devices like the HoloLens I was talking about. We can have like tiny, tiny devices that can run on a coin battery that could still like run a microcontroller and do advanced things and do like wearables and stuff like that. So, but more importantly is how can you be combining and analyzing all these signals from all of these Internet of Things devices and what can you do with them? So it's funny because security is actually one of the big things. It's the number one concern in a lot of things, but especially in IoT, because the more devices you're putting on the network, the more vulnerable you can become. I remember when I started my career in the early 90s, we used to say like the most secure box was the one where the network cable was not even plugged in the wall. Then that was secure. But of course now it's not really an option anymore. We've got wireless, we've got everything. And it's funny, I was ready to come here with this slide to talk about, you remember like earlier this year, I can't remember exactly what the date was on this, but it was like 2015. So over a year ago, these researchers have basically hacked into a connected car, a Jeep, to prove how dangerous connected cars could be if they're not secure properly, because now you could hack into a car that's still driving with human beings in it. And we already see what hackers can do when they go for like malicious intents. Imagine if they have the power to kill people by diverting vehicles and having them hit each other or whatever. Some will just do it to goof off. Others will just do it to really cause like mayhem. The funny thing though is that, and funny in a, not in a ha-ha, but more of a coincidence kind of way, is that my slide is kind of obsolete because there's a bigger news story that came out a few days ago. You probably heard of this one, right? On Friday, the internet was brought to its knees. Why? I mean, of course, not everybody is affected. It was routers that were basically at DNS that were affected. So depending on where you were in the world and which sites you were trying to get to, those sites either were available or were not available. And why attack a site when you can attack basically a traffic light that leads you to that site? And those sites were brought down, those DNS servers were brought down simply with IoT devices. IoT devices that were running with like unsecure protocols, with default usernames and passwords that are so easy to hack into, and you can just drop a few pieces of code in there, and then they become bots. They become bots in a massive, massive network of millions of devices worldwide that were all working in concert to attack these DNS servers. And to me, that is now the best example of the primary challenge that we have in the world of IoT, which is security. Does it mean we should stop? No, it's like anything in life. We still do online banking, right? And it's not stopping us because that equation has been dealt with. And yeah, sure, there's a few breaches here and there sometimes, but overall, I think nobody here really got screwed by online banking in general. If you got screwed, it's probably because you opened up an email that had a virus that spoofed you into going to the wrong site and giving your password, and then they stole your money. But the bank itself was still secure. It's your machine that was not. And now it's your baby monitor at home and your VCR and your DVR and your little like cameras, home garage networks and things like that that are vulnerable. And if yours is fine, there's other people in the world that it's not. How many times have you, I mean, we're in New York City, right? There's a lot of apartments all around us. Now it's not really a thing, but I remember like years ago, you could just go sniff around for Wi-Fi networks around you, and you could basically find all these Linksys routers, and you could log into most of them with default username and passwords, right? We've all done it, right? So it's ridiculous. And most of the time it was just to show like, hey, come on, seriously, secure your stuff. Now people are getting on to, of course, they're getting a little more educated about it, but it's going to be a new wave of devices that will have to do with this. So anyways, so IoT, the revolution starts with an idea. And the idea is usually going to be things like, what if my things could tell me like whenever they're going a place they're not supposed to go? Or what if I knew what my things were when they were going to break ahead of time? Or what if I could tell when it's the best time for my thing to do X, to do something? The whole basically dream of the smart grid, where our homes and our apartments are going to be connected to a smart grid that will analyze the supply and demand and the prices of electricity so that you can basically have home appliances that will start their work when the electricity costs are at the lowest and when they will wait on standby when the electricity costs are at the highest. So that means you could pre-load your washer and your dryer, and they're not going to start right away. They're going to wait until maybe it's not sweltering hot outside and everybody's running their ACs in New York. And maybe in the middle of the night when it's more cooler, now you can actually run it because the energy price is going to be lower. But instead of monitoring that yourself, you can have appliances that will talk to the smart grid that will then decide when to do these things. Or whatever. I mean, this is just one scenario out of many. And there's a lot of other scenarios like this. Basically, what if I just knew where my things were right now? Or what insights can I find for all my different devices? And what if I could use all this telemetry from devices for a next generation of devices that I'm building or working on? So if we look at, let's take a single device. A device can be anything. It could be a little sensor on a bigger device, or the device could be running on its own, connected to something. And the device can do usually one of two things. It either collects data from something, like it's a sensor, or maybe it controls something. It's waiting to receive a signal to turn on the light, or unlock a door, or basically just trigger something on the machine. So there's the two sides. There's the control part, and there's the telemetry part. And then there's the data that's going to come out of that device. And then we'll have to secure the device. We already talked about that. And then there's going to be all the insights from that data. Because you can say, like, tonight I'm just going to use a simple like temperature sensor. That's going to be very simple to return a temperature and then maybe raise an alarm if it goes outside of a threshold. But over time, the insights can be a little harder to deal with because you might have a lot of different sensors and the patterns are not necessarily linear. Like we have a project we've done with Fujitsu. It's best project name ever, by the way. It's called the Connected Cow. Yeah, Connected Cow. It's, in a nutshell, it's basically using pedometers and gyroscope like IMUs as anklets on cows to trace their patterns when they're moving around so we can detect a certain pattern that will identify if the cow is going in heat, which means that it's the best time for artificial insemination for that cow, which can bring the success rate from about 40% to about 68%. So for a cattle farmer, it's basically directly affecting their bottom line. And this is a project that we've done with Fujitsu, and it's live, it's in the world right now. But of course, it's not going to be just a linear thing or a number of steps. It's actually looking for patterns in the steps to determine exactly if the cow is just, I don't know, scared, or if it's actually in heat, or if it's just moving around a lot, or whatever. And yes, we're using Azure and machine learning to basically analyze all that data. But then, of course, you'll have a lot of devices. IoT is not about one device, it's about thousands of devices. It's about millions of devices. Sometimes it could be your devices, sometimes it could be other people's devices, and they're all going to be connecting to this cloud. And then you'll have to monitor all that data in real time. So how do you do this? So aside from hiring an army of interns to stare at screens, you'll probably need better methods to analyze all of this, monitor, and then looking for patterns and insights. The bottom line is there's already too much data today that we're generating that it's humanly impossible to analyze it by hand. We basically need software to do this. And then, of course, these devices, you'll have to manage them, know where they are, you'll have to patch them, you'll have to retire some of them, you'll have to activate, deactivate them, do firmware updates, and so on. And then you'll want to visualize and manage all of them. So the bottom line is the Internet of Things, if I can explain it in 4 buckets, It's basically the things themselves that we connect. It's the connectivity, it's the data, but then it's also the analytics. And there's too many people in the world of IoT that focus too much on the first three, but not enough on the last one as well. So what do we have to offer you for this? So in the world of IoT at Microsoft, we kind of have like two areas. I'm only going to focus on one tonight, and very briefly, of course, because it's a pretty big side of things. So Windows has been in this world for a very long time. Windows Embedded is running on, I don't know what the exact number is as of late, but it's something like over 50-60% of all ATMs in the world are still running Windows. And they're running an embedded version of Windows, and you don't see it, of course. When you go get 20 bucks at the ATM, it's not like you can Alt-Tab to play solitaire, you know? It's a shell experience, it's a kiosk, and it's secure, but it's running Windows under the hood. There's also a lot of Linux, there's also a lot of other technologies as well. I'm sure you can see, like, I've seen Windows machines crash, I've seen Linux machines crash. Yeah, the moment you see a machine that's got an issue, yeah, sometimes it gives you a glimpse into the internals of what's under the hood. So, but I'm not here to talk about Windows tonight. There's a lot of things I could cover there. I've covered it at my meetup. I'll cover it again there. And I would be happy to come back and tell you more about Windows IoT. Tonight I want to talk about the cloud side of things. The cool thing about the cloud is that it democratizes everything. It democratizes IoT. It means that the little guys, the independent developers, the moonlighters, and the small startups get access to the same technology as the big guys out there. And we can all scale. So that means if you build a great solution, you can scale it to 5 devices, or if you scale it to 5 million devices. And in the end, it's the same solution thanks to the cloud. It used to require a lot of engineering to architect a solution for this. But now, you design it for one, and you run it in the cloud for millions. So we're going to look at Azure IoT and everything that comes with it. So you'll see how it's basically like any cloud system. It's self-service. It's pay-as-you-go. You get a portal for everything. You've got global reach. And in terms of security, of course, you've got end-to-end security in there. And the cool thing is that, unlike what a lot of people might think, because it's Microsoft, you have to remember this is 2016, not 2005. So that means you can use Windows, you can use Embed, you can use Linux, you can use iOS, you can use Android, and you can use a whole bunch of other hardware and operating systems and languages. Everybody is welcome in Azure, and everybody is a first-class citizen in Azure. So the main services I want to talk about are the IoT Hub, Stream Analytics. So IoT Hub is going to be our main ingestion queue. This is going to be like our giant inbox, if you will, for our IoT devices that will let them send in telemetry. And it's also going to act as an outgoing point as well for command and control. We'll talk about Stream Analytics as well. Stream Analytics is pretty cool because it's, as you get a lot of data moving in real time, the best way to explain it is if I tell you, for example, to do a query against static data or against a database. I mean, all the coders in the room know how to do a query, right? If I put it in real-world terms, if I point at a parking lot and I say, go count the number of red cars in a parking lot, as developers, you know what kind of query you have to run, right? But now if I say, go count the number of red cars on FDR, or on the West Side Highway. Like, whoa, okay, that's a different kind of query because I have to know between which point, and for how long do you want that count. And the idea of a streaming query is that the data constantly changes, therefore the answer constantly changes. So it's not a query that you run once and get one answer, it's a query that's constantly running in real time. This is what streaming analytics do. And we have a great service for that basically lets you use a SQL-style querying language to actually query moving data. Because your devices will not pause when they send you data. I skipped one thing here. We'll talk about storage, of course, because, of course, you can't do anything without storage. We have app services which can be used for a backend for apps or for websites. Power BI, of course, is our desktop application, which can be embedded into a website to actually do advanced dashboarding and beautiful visualization. And then also logic apps to actually run jobs in the cloud. These are just some of the services in Azure. Azure is a monster of services. We have so many services, and I'm not going to go into explaining all of them. The bottom line is we have a whole bunch of infrastructure services. We have a whole bunch of data centers. We already announced 34 regions worldwide with data centers, and 28 are already online. we have way, way more data centers than Amazon and Google combined. And I am not kidding. It's a well-known fact. So yeah, we can scale, and we can bring the data as close as you need it to be. So this is a lot of services to deal with, though. So wouldn't it be great if somebody could just like whip this up for you like in a few minutes? And there's one way you can do it with something called our Azure IoT Suite. IoT Suite is basically a part of our portal where we will pre-provision all of the key services that I outlined that you need to get IoT, stream analytics, and then event hubs and storage and Power BI and dashboard and a website and queries and everything. So you can get started in minutes. You can then modify it from there. Be warned, this is not cheap, okay? Because it will spin up so many services in the cloud that, yeah, if you have Azure credits or anything, it will consume a lot of them. This is for real-world IoT scenarios. What I want to show you tonight, though, is how you can actually get started with a few of those services, either for free or for very cheap. And in terms of cost, by the way, because I know it's always a concern, especially when you want to dabble with this, we have some programs actually to help software developers and startups if they want to get started with all this stuff for free. So let me just ask you a question. So raise your hand and leave your hand raised if you are in a small startup or if you work for a small startup. Okay, keep your hand raised. What if you are an independent consultant or independent contractor or developer? Raise your hand as well. Everybody keep your hand up. Okay, cool. So all of you people, for example, could qualify for our BizSpark program. Our BizSpark program, in a nutshell, is we basically shower you with free software and free cloud for 3 years with no strings attached and no commitment for anything. So it's called BizSpark, Microsoft BizSpark. I can tell you more about it afterwards. You can pay me separately. I don't want to turn this into a sales pitch. But the bottom line is it's not a sales pitch because I give you free stuff. You'll basically get free software and free cloud with no commitment to buy anything. You keep all the licenses, and you get it for 3 years. And you get it for 5 developers. For an enterprise to buy the equivalent using an MSDN subscription, it would cost $100,000 over 3 years. We give it to you for free. So basically, all this stuff I'm talking about tonight, all of you that want to just play with this on your own or in your startup, you can do it all for free. Now, Azure IoT Suite basically will help you provision. Imagine that you have a bunch of devices, and then you have a new ingestion point, which is going to be an IoT hub. And then behind the IoT hub, you'll have stream analytics to analyze the data that's coming in. And then from there, you can use either an event hub, which is another type of queue, very, very cheap queue for transient data that you can use. And then also you can use storage blobs where you can go and store either in tables or in blobs all of your data. And then behind all of that, you can use websites, Power BI dashboards to basically present the data to your users. And you can also store everything in NoSQL databases like DocumentDB. And you can also connect it to any other system external that you have, either in Azure or outside or on premises. So if you want to learn more about IoT Suite, the link is right here. But I'm going to show you some of the individual pieces tonight that are important. The first one is the IoT Hub. The IoT Hub is it's a queue that's basically designed completely for IoT. It's kind of a service-assisted communication system. Think of it in a way as it's like an inbox for devices. That's one of the best ways to describe it. It's a box where basically your devices can go and send all of their data in there, and it will be ingested in real time. But better yet, you can actually do command and control where you can send a signal to a device. And it's device to cloud messaging and it's cloud to device messaging. But anybody who's ever worked in IoT knows that cloud to device is pretty hard because there's no DNS for your devices, there's no addressability, there's no unique identifier. So how do you contact a device? But we actually do it using the same kind of technology that your cell phones, for example, are using for push notifications, by reversing the communication over HTTP using a technique like heartbeats and long polling. And that basically allows you to have a device that you can send a signal to it. If the device is offline, it's going to come and check it whenever it gets online. If it's online, it gets it automatically. So you can actually do commands that you send down, like command and control. You can do cloud scale messaging completely. You can monitor all of your devices to know where they are, what they're doing, are they active. And this is the important one. You get per device authentication. Because one of the risks in IoT is that if you have 1,000 devices and then some rogue pirate shows up with 1,001th device, and they try to plug it into your system to try to basically hijack your IoT hub and your IoT infrastructure, but it's a rogue device with some kind of malware on it. The IoT hub will completely refuse any device that has not been pre-registered with it, and it's completely secure. With the proper devices that do support it, it supports like security infrastructures like TPM chips and things like that. We can also do software emulation of TPM if it's a weaker device like, I don't know, a Raspberry Pi. And so we can do full end-to-end security with this, and every communication is secure as well. IoT Hub will not allow any connection to go over flat HTTP, for example. It would have to be HTTPS, AMQPS, or MQTT, which are all secure protocols for IoT. It's multi-protocol, like I just said. You can do multiplexing, so using the same connection, you can do cloud to device and device to cloud. And the beauty, of course, is it's multi-platform. So it doesn't matter if your device is connecting from a Windows device, a Linux device, or any kind of other device. It could be as weak as an Arduino with a Wi-Fi connection that speaks with something like C to connect directly. It could be an iOS device, an Android device. It doesn't matter. We're full multi-platform and multi-language. So that's the architecture, what it would look like. You would have either devices that are themselves IP capable, like a Raspberry Pi, for example, is IP capable. But if you have a device like I have tonight here, I have an Arduino 101, which is nice. It's got like a Bluetooth connection on it, but it doesn't have Wi-Fi. It doesn't have an Ethernet port. So it has to rely on another device known as a gateway or a field gateway, which is a bigger device that would then connect to the cloud on the behalf of one or more devices, which is a standard topology in IoT, where you would have maybe 100 or thousands of devices that go through a gateway, and then the gateway connects to the cloud. Or you can also use cloud-side gateways, where maybe you have a device that speaks MQTT, or maybe a custom protocol. Maybe it's an old 15-year-old device that doesn't speak any of the modern IoT protocols. So then you could have that device connect to a cloud gateway, and then the cloud gateway will use a modern protocol like AMQPS to connect with the IoT hub. The bottom line is, no matter what device architecture you have, you can basically bring your data to the IoT hub, where one single IoT hub can actually do 1 gigabyte per second of ingress. So you can just scale it as much as you want. To communicate with the IoT hub, of course, you'll need an SDK. So that means you'll go and you can just go to GitHub, and we had a whole bunch of SDKs that are full. All of our SDKs are open source. All of our SDKs are cross-platform, so we support TI, RTOS, Linux, Windows, iOS, Android. You can use C, Node, Java, C#, Python, or any .NET language. Yes?
No Swift or Objective-C?
No Swift. Well, that's part of the iOS and Android SDK, actually. You'll be able to use them.
So the language I can use, or?
As far as I know, yeah. I'd have to check, but I'm pretty sure because we have native SDKs for it. So the question was no Swift or Objective-C. I'd have to double check, but as far as I know, that's part. The iOS SDK will let you use any of the iOS languages for it.
So it's not only like that's how Xamarin.
Well, it's Xamarin compatible. So if you want to do C# with iOS and Android, you can. But you can also. I'm 99% sure because I know all of our other services like App Service already have native SDKs for Java, Android, and for Objective-C and iOS. Swift, I'm not sure what the state of our SDK is, but definitely Objective-C. And it's all very easy to get started, and I'll show you a quick demo of that. Beyond that, of course, it's important to make sure that the devices that you buy out there, or maybe the ones that you build using common commodity hardware, will actually work with this. So we have a whole network of partners that can actually bring their devices that they're already certified for IoT with Azure, and we have SDKs for them. So I'm going to show you a quick demo here. Well, how many do I know on time? Okay, 8:20, good. It's basically, we did a lab last week. So it's too bad that I couldn't do this session before because I would have invited you to this lab. And in this lab, just to give you an idea, the little hardware setup that I have here, we actually had over 60 of those, and attendees got to leave home with them. It was worth over $250 of free stuff thanks to Intel. And it's a simple lab architecture where, first of all, we use an Arduino 101. So it's kind of like an Arduino Uno, but instead of being an 8-bit Atmel Mega CPU, it's actually a 32-bit Quark, and there's also another small core in it. So it provides you with a stronger architecture instead of just an 8-bit microcontroller, more memory, more CPU power, and it's got built-in Bluetooth, which is pretty cool. So and it's only like $5 more. And then on top of that, we put like this little shield. It's from Seed Studio that basically lets you do like this quick connectivity with little flat cables. So it's good for prototyping. You're not going to go to production with this. But if you just want to plug together quickly, I need an LCD screen, I need a temperature sensor, I need a potentiometer, and I need like a buzzer. And there you go. I just plug them in quick. I don't have to do any breadboarding, no soldering. It's pretty quick. So it's a shield that goes on top of the Arduino. We connect, there's a rotary angle sensor, there's an LCD display, and there's also a temperature sensor in there as well, and a buzzer. Then, because this is a device that does not have an IP address, there's no addressability with it, it doesn't have native connectivity to the cloud, we actually use the paradigm of or the pattern rather, of a field gateway. In this case, our field gateway is an Intel NUC, which serves as an IoT gateway. The NUC is these little devices that can run Windows or Linux. In this case, this is running, it's running an Intel Atom architecture, and this one is running Wind River Linux on it. And then this one was connected, then that one connects to the internet. So all of this is not connected to the internet. It's basically communicating directly over serial, over USB. But of course, in a non-lab environment, you would use something like either Bluetooth, maybe a closed loop Wi-Fi, or maybe even like a Zigbee, for example, as a good way to communicate between your devices and your gateway. And then we program this actually from a computer. The lab allowed people to actually do Mac OS, Windows, or Linux. And the whole lab, by the way, is online on GitHub. I'll give you the link. So if you want to get the hardware and rebuild it yourself, as I said, it's going to cost you about maybe $250 or $280 of hardware to do it. We have other starter kits that can start you under $50 as well. And I've got links for all of those. This is the one that I chose to do because it was ready to go. And it's a pretty cool setup. And then this is the client side, if you will, the field side. And then there's the Azure side, which begins with the Azure IoT Hub. And let me just show you quickly that part, and then I'll dig deeper into the IoT architecture and how that would fit in. So let me just jump quickly. So first of all, in terms of, so that's the link, by the way, to go to that camp. If you want to get all the information, it's already on GitHub. It's very detailed information there. So it's sitting right here in GitHub, and then you can check the whole lab architecture, the requirements of what you need with links to everything. The main website for Azure, basically you go to azure.com, you can go to Azure IoT, and then we have a whole learning plan for the different pieces of Azure that you might need in this. And this right here is our portal. So this is the Azure portal. This is my portal right now with some of my resources that I've already created for this lab. So this is you can see all the Azure regions are very healthy. We've got some of my resources are here. This is my lab right here. I have an IoT hub, a SQL database, an event hub, a streaming job, a web app, a function app, which is serverless server-side functions. And then I have 2 storage accounts right here. If I go to the Azure IoT hub, so normally to create an IoT hub, you would just say like, hey, plus right here, new. And then under new, you would select, for example, Internet of Things, and then you would pick IoT hub. And then you answer a few questions. What's the name of the IoT hub? What's the resource plan? In what region do you want to run it? And things like that. I don't have a lot of time tonight, so I'm not going to do live creation in front of you. But the lab walks you through all of this. We have tutorials for every single service that's already available. And here you can see that I have my architecture right here is sending the information to show you what my setup looks like. Let me just launch my document camera here. So this is my little setup that I have. So the Intel NUC is right here. You see the little box right here? So that's basically the NUC. It's a Linux box running an Intel Atom architecture. And then here what I have is I have an Arduino 101 that's under this right here. That's the Arduino 101 right here. And it has a shield on top of it. And the cool thing with these shields is that they basically just let you do like plug and play electronics by picking the sensor that you need. It's a kit you can buy from a Seed Studio. And this way here, you've got some GPIO and you've got some SPI and I2C in there as well. So here, for example, I have a little buzzer on this one. Here I have a temperature sensor on this one. Here I have a potentiometer that basically lets me control the color of the screen. And here I have a little LCD that gives me, first of all, my IP address, which was kind of essential for a lab because we were SSHing into our box. Right now I have a screen here on stage. It's purely for debugging. That screen is my own. It's not something we gave away to people, but you can see my screen right here. Whoops, let's go sideways like this. It's very like retro, cool. It's just a little screen that I use, 65 bucks on Amazon, it's awesome. And it basically lets me debug. So I got my IP address right here. This is running a Node-RED application on this as part of Intel's IoT solution. I didn't want to show up with just a Microsoft solution here. I wanted to show how we work with partners and support other technologies. That's why I'm running Linux on this. I'm running Node-RED. And it's a modular, like drag and drop architecture that lets you create like a visual, basically creation, if you will, for IoT and decide like take the data, transform it, go to JSON, and then after that we can start applying different inputs and outputs. But I'm not really going to focus too much on the client side here. And then here,
How do you identify the end device?
sorry?
How do you identify the end IoT device at the other end, at the Azure end?
I'll show you. Yeah, so the question is, how do I identify this device? So as part of the setup for this lab, there was one step which was to create a device registration. So we can either do it using, there was two tools that we have. We have a graphical tool on Windows, and we also have a node-based tool. So it's a tool called IoT Hub Explorer that you can just get through NPM. And then on a command line using Node, you can actually simply register a device, and then you're going to give your device a name, and then you're going to register the device with a SAS token that's connected to your IoT hub. And I'll show you where the SAS token is. And then once that's done, the device is registered on the IoT hub, and you end up with a device-specific connection string. And that connection string goes on the device itself. And then only that device, using that connection string, can actually go to the server. And there's, of course, some device architectures that would be a little more secure where you wouldn't have to, like in this case, you could just copy the connection string to multiple devices because it doesn't really differentiate between multiple Arduinos. But if you have a more powerful device with a TPM chip, then the SAS token can actually be tied to the actual TPM module so that it's now unique to this device. And you would have to generate a different token for different devices. And you can automate all of this through a job. So if you have 1,000 devices, you don't have to type NPM commands 1,000 times. That would be a little ridiculous. So we have a full SDK for that. So right now, this lab has been configured for IPv4, but our technologies are all independent from all of that. So and right here, what you can see is the temperature, very precise with a lot of decimals that's being reported. As you can see, my device is not calibrated because it's certainly not 33 Celsius in here. But of course, these are little cheap, like $1 sensors. So the first step you do before using them is you have to calibrate them. Right now, this one is configured so that if it goes over 40 Celsius, then it will actually raise an alarm. There's two ways you can actually do this. You could have code locally on the client, but in this case here, we're actually going to send the data to Azure, and then using Stream Analytics, we're going to splice the data and then look for these rules. So basically look for these alerts based on rules, and then we're going to send the data to a different storage area so that we can detect whenever there's an alert situation like this, and then we're going to send a command back using cloud-to-device messaging to buzz the device. In fact, I could actually do it right now. Let me just, I'm going to go all Mr. Miyagi right here. All right. And I'm going to start holding my device. Temperature should start rising. Whoop, I'm going to try to make sure the glare goes out of the way. And I'm over 40 degrees, so now it's giving me an alert. And it's going to stop giving me an alert. Right now, this demo setup is configured to check the data every 5 seconds. I could have put it every 1 second, but I didn't want to flood my IoT hub with too much data. And it takes a while for this to actually start coming down. And this is the annoying part of the demo, where I have to start speaking with a buzzer that's ringing in my ears. So anyway, so that's basically what the demo does. Now, how does it work? We're almost there, 40. My hands are very hot, apparently. Temp alert, 40.2. Come on, drop below 40. 39, all right, cool. we're done with this part. All right, so that's it. So that's the little setup right here. Now, if I come and look at my Azure setup right here, so here I can see my IoT Hub. This is daily messages. We have a free tier for IoT Hub where you can use it completely for free for 8,000 messages per day. So you're not going to go to production with this, but you can easily do some development, capturing data every 5, 10, 20 seconds or every minute, and that's usually going to be enough to do your development and debugging. And you can see the message count is actually going up. This is not like a real-time console right here. It's not, you would not use this for monitoring. You can actually create like Power BI dashboards that would actually look at the data in real time. We have some monitoring here where we can see the number of devices, the number of telemetry messages that have been sent at every minute. So we can actually turn on all this monitoring. If I look at my configuration here, you can see under devices right now, I only have one device that has been registered here. So it's called it's my Intel IoT gateway because the gateway is the device that connects. So I could technically have multiple devices that would go and connect to the cloud, but in fact, they're all funneling through the same gateway. So that's the gateway that's connected. And if I want to get my connection string after my device has been created, you can see here I have a primary key and a secondary key, and it's already been assembled into a connection string. So it's that connection string that I can copy to my clipboard, and then I would go and paste that into my client code, and that's the connection string that I would be using to connect to the cloud.
Is there any correlation to it? Is this like something that's going to go in a web browser? Is this like a query string kind of a thing?
It's not a query string. It's a connection string that goes on the client-side code, but the communication with the server is entirely secure over HTTPS, MQTT, or MQPS. So there's no sniffing on the line, and it will actually, this is simply what's going to allow the device to connect to the IoT Hub. And then after that, once the connection is established, now it can start sending telemetry data. But it's going to use the same connection to actually do the commands that will come down from the server.
What's the format of the data on the Azure and all the data coming in?
So what's the format of the data in Azure? It can be anything you want. Right now, we're using JSON data, but you format it in however you want. So JSON is pretty universal in terms of it's relatively lightweight without having to go too low-level binary. But if you wanted, you could. I mean, ultimately, it's whatever the protocol will allow you to send. And then once the data goes to the server, then you'll see how you can actually transform it and bring it to other areas. The beauty of JSON, though, is going to be very easy to do queries against it. Because that you want to be able, of course, to do query against your data. Because in IoT, you have a lot of data that's coming in. But typically, you're not going to keep all of it. 99.9% of the time or so, your data is going to be all green, all good. It's only sometimes it's going to go outside of those ranges, and that's what you want to keep. The rest of the time, you would keep a spot check maybe every 50 minutes, every hour or so, and then it's going to maintain a heartbeat to make sure the device is not going to go dead. And the bottom, and that, of course, the device is operational, even if it's not sending. We maintain a heartbeat with the device, or rather, the device maintains a heartbeat with the server.
I don't know if I'm reading too much into the semantics of it, but it says primary key, secondary key. Are we talking about cryptography here, or maybe?
No. The primary key. Okay, the question is this about cryptography here? No, it's not like these are not asymmetrical keys. This is basically just alternate keys. So you could basically have a primary key and a secondary key used for different purposes. They're both equal. They will both let you in. But then later you can then decide if one of them becomes compromised, you can regenerate one of those keys if you want. All right. So anyway, so I have my device right here. The creation of this device, as I said, we have a little Windows utility to do it, or you can also do it from a Node command line and you install that command line interface using npm. It's called the IoT Hub Explorer. And the IoT Hub Explorer also lets you connect to an IoT Hub so that you can see the data coming in real time. Because right now an IoT Hub, it's kind of a transit storage. You don't have a way to go in and look at the data that comes in. But then after that, to actually look at those shared access policies right here. So this is the way that you would connect. You can actually have different policies with different levels of privileges on what you can do against the IoT Hub. So IoT Hub owner is the one where you've got access to everything. You can connect, you can service connect, and you can do a registry write as well inside of a registry to register a new device. So when you register a device, you're going to use that connection string right here, which is kind of like a master connection string, if you will, for your IoT Hub. But later, we're actually going to use in the solution the service the service policy, because this one only has a service connect permission for it, so it's less permissive, therefore it's more secure. We can also have a device connect, so you basically choose these levels of policies. I know I'm going fast and there's a lot of principles here, but then just to show you quickly the rest of the solution, because I'll jump into the other pieces, I wanted to show you the IoT Hub first. So the rest of the solution after that, I should have removed the build on this. Okay, once the data comes into the IoT Hub, what do we do with it? Well, the first thing we're going to do is we're going to run a stream analytics job. The stream analytics job is actually going to have 2 queries in it. One query is going to take all of the data. Basically, it doesn't filter any data. We take it and we basically save it all in a SQL Server database. It's a relational database. We could have used a MongoDB database in a VM. We could have used a DocumentDB, which is our NoSQL solution. Could have used whatever you want. In this case, we're using a relational database. And then there's going to be a second job, a second query in that job that basically looks for temperatures that are above 40 Celsius. And whenever it detects one of those, it basically dumps an entry into an event hub. An event hub is another type of queue that's very, very cheap, but it's not device-driven. So it doesn't have the ability to secure per device. It cannot reverse the communication to do command and control either. So it doesn't give you as many functionalities as an IoT hub, but it's much cheaper to use though. Once that's done, then we have a little web app that will basically take data all from the SQL Server database and just display it. This is our classic little temperature chart that's going to show us the current temperature with all the readings that are coming in. But then we're also going to have, and this is going to read the data here, and then from your computer, of course, you're going to come and ping that via web browser to see our web app, and this is hosted inside of an Azure app service, which is used for mobile backends and for web apps. And a web, you can run whatever you want in it. It could be basically a Node app, it could be a pure HTML, it could be ASP.NET, it could be Python, it could be a PHP, it could be whatever you want. WordPress even. We have a lot of templates for everything. This one is not like an advanced website, it's it's kind of a programmer interface, if you will, using programmer skills. So it doesn't look like the most beautiful website, but it works. And then here we have an Azure function. An Azure function is basically for serverless jobs that are running in the cloud. And those jobs, basically what they're going to do is they're going to come and read the data from the event hub. And then from there, they're going to query a script. They're basically going to be a job that will run. And then it will store all the alerts in a storage account because the event hub and the IoT hub are transient storage. This is not storage that you keep all the time. Whenever you create an event hub or an IoT hub, you choose a retention policy to say, like, I want to keep it for 1 day or I want to keep it for 2 days or whatever. And after that, this data just goes away. And then here we're saving those alerts in a storage account. And then we have our function, once it detects those alerts, then it will initiate a cloud-to-device communication with the device in question, the one that's raising an alarm. And then that's how we're basically sending a command over to raise that buzzer that's running on that device. So this is where we reverse the communication between the two. And then behind this, because the website has a little table of data, we also want to have a nice little chart. For the chart, we're using Power BI Embedded, which is a nice dashboarding solution to do like a beautiful visualizations, kind of like a la Tableau, if you will. So we're basically a Tableau competitor with that product. And we can actually embed it directly inside of a web page. So that's why I built it in pieces, because I don't want to scare you with this all at once, because it's a lot of stuff to cram into one slide. But that's kind of like a simple bread and butter IoT solution with telemetry and command and control. And of course, we could scale this for how many devices that we want. And I'll show you a couple more pieces of code in this. Yes?
I have an interesting question.
Yes.
I like all the local resources. As far as the Azure, do you guys have something for, like if you have like a Microsoft environment composed of SQL servers, web servers, SharePoint servers, BI servers, why you guys are not producing something for the current environments that we have locally so we can...
Okay, so basically
I love this, but I want to manage my current environment, my IoT,
Right, so-
IoT to my current environment.
So in a nutshell, if I understand your question properly, so this is a cloud-based solution, and you basically, if you already have like an infrastructure at work in the office in your data center, then can you reuse? Yeah, well, the bigger companies do, the startups don't. The startups are usually mobile first and cloud first companies. But anyways, but I totally understand. Trust me. I mean, over 80% of the enterprise uses our cloud. So yeah, we do have all of that. And in fact, the way it works is those services typically you will run in the cloud because you need the scalability of the cloud for the number of devices you have to run. But for example, that SQL Server database right here, it could actually be sitting in your data center over a VPN connection where you have a site-to-site communication, where basically Microsoft is in a very unique position because we're the only ones that have a truly what we call hybrid cloud, where some resources can be in the public cloud, some resources could be on premises in your data center, and they're connected over a site-to-site VPN together, but you're managing them, all of them, in the same way. And unfortunately, this is a whole other topic to go into that. So do we have an IoT? Oh, so we have an Azure stack that basically lets you bring Azure services over to your environment, but not for IoT. IoT is something that the sheer number of machines you would need for this, first of all, would be way too big. And most companies that do IoT actually prefer to turn over to the cloud. It's not really been a big ask that we've been getting. Most companies that have been asking us to do this, they want to run different kind of processes. Let's table this for now. We can catch up afterwards. I don't want to be dismissive. I don't have a lot of time. But yeah, the whole hybrid cloud, on-premise versus cloud, that's a whole topic for another day. So let's chat afterwards. Yes?
In a practical application, how would you protect or can you against a sensor going bad?
So in a practical application, how would you protect against a sensor going bad?
So it gets stuck at 37 degrees. So
Yeah, so there's, that's tricky because it depends on the nature of the sensor that you're using. Some like really cheapo sensors and everything, of course, there's not much you can do other than realize that the reading, even to the lowest decimal, has never changed. So you could analyze for something like this. But of course, more advanced sensors usually will come like with calibration tools and instrumentation that will basically allow you to basically detect these kinds of things. But again, we're kind of like device agnostic when it comes to Azure. So we give you tools where you can actually we can do firmware updates, for example, remotely. You can actually send commands to reboot a device remotely. We've got all these device management features. I have a few slides on this, but I'm not going to have too much time to focus on that. Let me just show you a couple more pieces of the implementation in the back end. So if I look at other services that are very interesting, like the streaming job right here. The streaming job, the way it's configured right now is you basically configure it between an input, one or more inputs, one or more outputs, and a query that goes in between. The input that's been configured here, I'm not going to click on every one of them, but this is basically, it says the input is an IoT hub. So we say which IoT hub we go read from, we provide a security for it, and then the output, we have two of them. We have our alerts event hub, and we have our SQL database where we dump everything that comes in. And then the interesting part is the query that goes in between. The query is basically, it's a query language that looks a lot like SQL. So we actually have two queries inside of this job. The first one here says, can you guys read this? Is it too small? You guys okay? All right. So the first one, you say select the device ID and the timestamp and the temperature, and then into the SQL database from the IoT hub. So it's kind of the equivalent of a select star and dump everything there. The second one is the same thing, select timestamp, temperature, device ID into alerts, which in this case, alerts has already been configured as an event hub. And then here we say from IoT hub, but we put a where clause where we say where the temperature is over 40. Because this is data that comes as a JSON data, we can actually just go query a column, if you will, in there. And the beauty of this is that as the data is coming in, the query is running constantly. It's a near real-time query, if you will. And then it will process the data, and then if it detects something that goes over 40, it dumps it into the event hub. Then once we put this into the event hub, so there's my SQL database, it's just a table that stores everything. I have a web app right here that basically reads everything from there, so I can click on my web app. So I could go show you the source code of the web app, but that's not very fascinating. The key part you want to see is what it looks like. So I'm going to copy this to clipboard, and I'm going to open this right here. It's live in Azure right now. You can go ping it if you want. And this is a simple table where basically shows me my device. So I could have more than one device, of course. It shows me my last 20 readings with the timestamp on them and the temperature that showed up on this. And then here I have my embedded Power BI chart that basically shows me my data. We can see that I had, right here I had a spike. This is my spike from tonight right here actually that I just got. Okay, so that's my Power BI embedded chart. So, and of course, you could go into the Power BI desktop, create more advanced dashboards, and come and plug them into your website. And this is kind of a dumb website. It just refreshes every 20 seconds. But of course, if you created something a little more dynamic, of course, it would be a better experience. But as I said, this is programmer art. And then to do the reverse communication, let me show you a piece of our, so if I go to our products right here, and if I go to Internet, Azure IoT Hub, this is where you're going to get the main Getting Started page. And then in the Getting Started page, you see Getting Started with Azure IoT Hub. We have the IoT starter kits. I'll show you the slide for that. But then when you go to connect your device, we have a nice page where we show you basically what we support. So first of all, you can select your device. It could be a BeagleBone, a Minoboard Max, an Intel, Edison, Freescale, Raspberry Pi, TI, Dragon Board. It could be your computer, another type of device, or even if you don't have a device, it could just be an app that you write to prototype this. Then select a platform. Could be Linux, could be Windows, could be Mbed, could be TI, RTOS. And we have a full compatibility matrix where we show you which versions of Linux, the versions, and all of that. But the key part that you want to see is this one right here. So for example, let's say I'm on a plain Arduino that does have Wi-Fi connectivity. I'll be writing it in C. So that's the code right here to initialize the IoT Hub. You would come and paste your connection strings that you got. So right here, you put your device connection string that comes from the IoT Hub that's been configured. And then here we create a message callback for the reverse communication from cloud to device. And then right here, we have this receive message callback that basically whenever we receive a communication, this is the code that's going to be running here. We get the data out of the IoT Hub message. And all of these, of course, have SDKs for them. So that's why it's very high-level code, because we have fully baked classes using C headers that you can use. Same thing, C# is a little more elegant to actually look at. It's a little more human-readable. You can see like device, create a connection string, send an event, receive a command. And then right here, we can send an event like this. It's just a few lines of code to send an event to the IoT Hub. And then when you receive a command, it's actually very easy. We just have a loop that whiles, and then that basically receives the data from the server. And it's using the same connection for both. And then if you want to see how that would be done, like in JavaScript, we have the code snippets for it, or in Java, and we have a whole bunch of other SDKs that are in GitHub. All of our SDKs are in GitHub, and they are open source. We're very, very, very transparent when it comes to open source. If you have not had a chance to work with Microsoft lately, this is not your father's Microsoft from the early 2000s or the 90s, okay? Well, I mean, GitHub recently published their list of biggest contributors to open source, and Microsoft was listed as the #1 company with the most open source contributors. In all fairness, they did split Angular and Google in two. It has two separate entities. If they had joined them like they should have, Google would be #1. But still, I'll take Microsoft at #1 or #2 any day when it comes to open source contributions. So we have, for example, our gateway SDK. If you want to build your own gateway, we have our own gateway SDK, full open source in the cloud that you can run on Windows or on Linux. So that means if you want to create your own field gateway, you don't have to learn how to build it yourself. We have a nice SDK that lets you build this. So that's kind of like the quick and dirty of the solution. I wish I could spend more time to dive into the architecture, but of course, that's a lot of stuff. And hopefully that gave you a little bit of an idea on how it works. Beyond that, we have, I'm not going to be able to go too deep into this, but if you want to do device management, so for example, knowing which devices are where, how do you activate, deactivate them, go by different topology, we have that. The gateway SDK, so you can create your own. We have an SDK all in open source. The starter kits, I have a slide to show you as well. So you can update the software on your devices. You can update the firmware on your devices as well. You can update the configuration. So we use a a construct called basically a twin device. It's basically like a JSON file that contains the data from the actual device and the mirror that's in the cloud. And then you can basically change the twin and then apply it. And then after it receives the job to update itself, then the device will come and update its twin to basically say at which state of the reconfiguration it is at so that the server knows about all of these things. So for example, if you have a building management where you have, for example, devices all split in rooms and the rooms split in floors, then you can basically create a topology where you can say, we're going to update all of floor 1, and then after that, we're going to go and we're going to update floor 2. And then we can even create permission groups as well for the security in terms of which devices have access to what and who has access to which devices. So if there's a floor that has some very, very sensitive equipment that not everybody has access to, and there's another floor that's a little more like open stuff. It's just like at Microsoft, we have these little devices on every conference room where you can go book the room directly outside of the room or remotely. Well, those devices are not really mission critical. But I can assure you that the devices that we have on our data centers and in our server rooms, well, those, of course, there's fewer people that have access to those. And you can't simply email them from Outlook like we can with our conference rooms. The device management, you can enroll your devices. You can bulk enroll them as well. We have a full SDK for that. You can organize them. You can maintain your devices by updating software and firmware. And you can also decommission devices that are either faulty, maybe that they're about to be replaced, whatever reason. You can actually do this remotely from the cloud. The Azure IoT Gateway, so basically lets you create your own gateway so that you can kind of like here, we're using an Intel gateway. The next step in my demo is actually to replace the Intel solution with our own Azure IoT Gateway instead to show how it works, both on Linux and on Windows. So to get started with all of this, we have these nice little IoT kits. For example, the Thing Dev Kit uses an ESP8266, which is a nice little microcontroller-grade device with built-in Wi-Fi. It's less than $5. The whole kit is less than $50. And we have nice tutorials and a walkthrough on how to connect each kit to Azure. So the link you need is just azure.com/IoT starter kits. All these kits range in price from anywhere from $50 to maybe $120 total. The kit here from Intel is a little more expensive, but we basically have a whole range. If you want to just experiment with this, it's actually super affordable. And we've partnered with some great companies to do this. The demo lab that I shown today, if you want to try it out, it's actually at this link right here. github.com/dxcamp/Microsoft Intel IoT Camp. These are the requirements. So these are the two main expensive parts. The NUC and the Grove kit with the connectors and the sensors is going to be about $240. And the Arduino 101 is about $30. And the rest is just software that you need. You need any machine. You need Visual Studio Code, which is our editor that is completely free and open source across platform. And Git and Node. We have a number of other labs as well for Azure and for Windows IoT, both. You can get them straight from, oh, I didn't put the link. Oh yeah, right here, ak.ms Code Labs. These are the IoT labs that we had at our Build conference. So the Build conference is like our big developer conference. So you can actually try them out here. There's a bill of material for each. There's yet another site that we have with labs. This one uses Johnny 5 and Fermata so that you can basically take control of a device from your computer, and it's at thinglabs.io/Azure. So basically, depending on whatever equipment you have, whether it's a Raspberry Pi, an Arduino, a particle photon, an ESP8266, we pretty much have a bunch of labs for whatever equipment you already have, or we have some cheap kits for you guys to get started. I have a bunch of demos on my GitHub for Arduino, Windows 10 IoT Core, particle photon. Some are cloud connected. You can get them there. And I also started a show earlier this year on Channel 9, which is our video platform at Microsoft. And it's a show for makers, aptly called The Maker Show. And it's completely technology agnostic. We actually did not mention the name Microsoft until episode 5. So, and episode 6 was teaching you how to solder. So it's a great show for makers. It's slowed down a little bit because our priorities have shifted and we're kind of busy with other stuff right now, but we already have over 40 episodes published to date. It's all available for free online. More places where we can get some great projects. We've partnered with Hackster. They're awesome people that have like a great community for makers and do-it-yourselfers. And Beyond that, these are more resources, including our Azure, our Microsoft IoT GitHub for Windows 10 IoT Core. But anyways, all the slides, you just need to take a picture of the last slide at the end, because that's where you can download the whole thing. And we also have a full day course, completely for free online on Microsoft Virtual Academy called Getting Started with the Internet of Things. It's going to show you some Windows 10 IoT Core, some Azure IoT, some Johnny 5, some Node stuff, some Windows Remote Arduino. It's a really, really cool course, and it's completely free. Microsoft Virtual Academy is our free online learning platform, kind of like Pluralsight, but free. And of course, we don't have as big a catalog as Pluralsight, but Pluralsight is a great partner, but we have tons of great courses here. And that's it. So slideshare.net/ActiveNick. This is the Science Fair 201 kit that as a kid, I had the 160-in-1. And I was drooling over the Radio Shack catalog at every birthday, at every Christmas, hoping that my parents would buy me the 200-in-1. I didn't even do the other 160 completely. I just knew that 200 was better than 160, so I wanted it. And I never got it. But 2 years ago, I bought one on eBay for 35 bucks. And it's full with all the parts and everything. And my kids, they're like one something here. They're 3 now. One day I'm going to teach them electronics with this. And we'll have fun, you know, building future IoT developers. So my demo stuff is on GitHub right here. The slide deck that you saw here is also here, slideshare.net/ActiveNick. I've uploaded it today. So it's the very last upload that you'll see on my SlideShare right there. So we started late, so we ran a little late. While I pack up, if you want to come and ask some questions, I'll be happy to answer more. But in the meantime, thank you very much for coming tonight. Hopefully that was interesting.
Thank you.
So Linda, I'll leave it to you.
Thank you, Nick. Thanks, everybody, for coming out, for hanging in there. I hope y'all learned a lot of interesting things that you might think of how it overlaps with your own projects. So thanks, and hope to see you next month.